Hello and welcome everyone to my channel Code with Ease. Today we are back with another question based on arrays. It is a medium level lead code question. It's called the subarray sum equals k. So in this we are given an array of integers and one integer k, and we have to return the total number of subarrays whose sum equals k. So first of all, what is a subarray? As it is given, it is a contiguous non-empty sequence of elements within an array. So contiguous means adjacent. The sequence of elements within an array are next to each other, they are adjacent to each other, and they should be non-empty. So the requirement is, given an array of integers, we have to find out the total number of subarrays that can be generated, but the sum of the subarrays should be equal to the given k. So as we can see in the first example, this is the array which is given 1 1 1, k is equal to 2, and the output is 2 because there are only two subarrays whose sum is equal to k. That is first one and second one, 1 and 1, and second one and third one. So in the second array 1 2 3, k is equal to 3 and the output is 2 because there are two subarrays where the sum is equal to 3, that is 1 and 2. 1 2 is the sum of these two elements is 3, and 3 itself is equal to 3. So that is why we have two subarrays whose sum is equal to 3, hence the output is 2. So with that, let's move to the whiteboard to understand the approach for solving this question. So into the whiteboard, this is the array that we have taken. So now we'll discuss the approach for solving this. First, let's talk of the brute force way of solving this question. So as we know, we have to generate or we have to find total number of subarrays whose sum is equal to k. So what is the first problem that we have to solve is to find out or to generate the subarrays. That is the first thing we have to do. Once we generate the subarrays, is then we can inspect every subarray and find out whether the sum is equal to k or not. In order to find or generate subarrays, we need loops, and we need two for loops to do that. Hence, the time complexity involved will be order of n square. And within the for loop, within the second for loop is when we have to start computing the sum of the subarrays, and then we have to check whether that is equal to k or not. Again, doing that to find out, to check, compare, to compute and compare sum, again that is going to take another complexity of n elements. So it is going to be another complexity of n, which we are going to do anyway inside the loops. So n square and then into n, so it is becoming a cubic time complexity, which is order of n cube. So all in all, if we go by the brute force way, the time complexity is not good because it is coming as exponential time complexity, and we would want to optimize the time complexity. So as we have seen that the brute force way has given a time complexity of order of n cube, and that is not quite good, and we would want to optimize this. So now we'll discuss of the optimal solution for this, how to optimize. So to do that we will use space, we'll use a data structure which is the hash map. So what we are going to do in this is, just as we were trying to generate the subarrays first and we were trying to compute the sum, check it whether it is equal to k and all of that, in this case, first of all, we'll generate a running sum of the elements. What is a running sum? Like in this case, if we see the second example, first we have the element 1. Then element 1 is going to give a sum of 1 itself. Then we are going to add the next element, that is 2, and 1 plus 2 is going to give 3. So in that way, we are going to pick one by one the elements, the current element, and add it to an existing sum variable, and that is how we are going to compute the running sum. Why are we doing that? We are doing that to check whether at any given point in time the running sum is equal to k or not, because that is what we want. The sum needs to be equal to k. If at all it is equal to k, we can consider that subarray as a valid subarray, and we can increment a count variable. So we can say that, okay, if the running sum at any given point is equal to k, exactly matching k, so we'll just increment this count variable, some variable we'll have, and then we'll just increment that. So that is about a scenario where there is an exact match. Now where do we need this hash map? So what we will do is, given these elements like we have 1, 2 and 3, we are going to store the sum and the occurrence of that sum in the hash map. So in the hash map, the key is going to be the sum, and whatever the occurrence of that, occurrence means how many times that sum has occurred, that is going to be the value of the hash map. So this thing we need to store. Why are we doing this? So after computing the running sum, point number 2, what we are going to check is whether the hash map contains the sum minus k value or not. If hash map contains sum minus k, we are going to consider that. Now what does this mean? It means that, okay, suppose let's say these are the elements 1, 2 and 3. So if we calculate the sum, first is 1, then 1 and 2 is 3. So 1 and 2, 3 is equal to k, because k is also given as 3. So it is a match. Okay. So we increment our whatever this count variable was, we have incremented that. Now 1 and 2 is done. Then after that we have another element called 3. So what is the current sum now? 3 plus 3 is 6. Okay. So before that we were storing in the hash map anyway the sum of 1, then the sum equal to 3. So our hash map looked like the sum is equal to 1, it occurred one time. The sum is equal to 3, it occurred one time. So far these are the entries that we have made it in the hash map. Now observe that currently our sum has become 6. Now 6 is obviously not equal to k, but it is greater than k. So what we are doing this check over here is whether the hash map contains sum minus k or not. What is the sum? 6. K is how much? 3. So 6 minus 3 is 3. And we do see that in the hash map we have an entry for the value the key as 3 and the value against it is 1. Now what does this signify? Now if the hash map contains this particular value, that is sum minus k, what does this signify? It simply means if I have, let's say from 1, 2 and 3, this much sum is equal to 6, correct? And if that is the sum minus, if I am subtracting a value equal to k from here, what is that k value is equal to 3, means this much portion. So from this entire sub array 1, 2, 3, if I am deducting or subtracting this portion of 1 and 2, what am I left with? I am left with this element 3, which is exactly equal to k. So we are just doing a back calculation that if the hash map contains the sum minus k value, then it means that we have a sub array whose sum is exactly equal to k. Like I said, 1, 2 and 3 is 6, 1 and 2 is 3. So 6 is this much and 1 and 2 is giving us 3. So 6 minus 3 is giving equal to 3, and 3 is exactly equal to whatever the value of this thing is, k is. So that is the whole logic of using the hash map and trying to do this check. So what we will do is, if the hash map contains a key which is equal to this sum minus k, we'll simply add it to our current count variable, saying whatever the count is, that much count plus equal to whatever the value against this is, which means sum minus k is 3. Against 3 we have a count, the occurrence, the value of that is 1. So we are just going to add that to our current count, and in that way our count gets incremented. Again, the reasoning behind this is, if I have a certain sum which is greater than k, then if I subtract the value whatever I have of k from that, I will be able to get the k itself. Like the sum over here was 6, if I am subtracting two elements, that is 1 and 2, 1 plus 2 which is equal to 3, if I subtract that value from here, I can get the element itself 3, which is anyway equal to what I am looking for, means the sub array which I am looking for. So once we have done this, at last third step is nothing, we just have to, whatever additions we are doing to the hash map, that we will just add. We will do a map dot put, we will add the sum, whatever the sum we have got, and we will add the occurrence of that. So 3 steps. First, compute the running sum, check if it is equal to k. If it is equal to k, increment the counter. Next, check in the hash map if you do have a value which is equal to sum minus k, means if at any given point in time the sum exceeds k, check in the hash map whether that is already present or not. If it is present, increment the count variable. And finally, just add it to the map, the current sum whatever we have got so far, so that later on when we are again doing this check, sum minus k, whether it exists or not, then these values can be of some help to us to compute the total number of subarrays. That's it. So this is the approach for solving this. Now if we do a dry run over here very quickly, so like we said, 1 is already stored, 3 is stored. Now the moment we get 6, so 6 minus k, like 6 minus 3 is equal to 3. So now our count, which was initially only 1, initially why 1? Because 1 plus 2 was equal to 3. So initially our count was 1, now to this 1, another 1 got added. So now the count becomes 2, and we are anyway out of the loop because the array has ended. And as we can see here also the output is 2. Here also we got 2. So in that way we have been able to find out that there are only 2 subarrays in this array 1, 2, 3, where the sum is equal to k, that is k is equal to 3. That's it. So with that, now let's write the code for this. So we'll start with the code changes. First of all, let's define the count variable. So initially which will be equal to 0. And we'll also have a hash map. Then we'll have a for loop to compute the running sum. We'll also define a sum variable, which will be initially 0. To this, we are going to add the current element, and we are going to check if the sum is at any given point in time equal to k. We're just going to increment the count. And next thing we have to check is whether this map, hash map, whether it contains the value which is equal to sum minus k. If it does, we have to get the count against that. So count will be equal to count plus map dot get. So this is going to anyway, this is for tracking the, so in this way we will get the count against that key and then add it to our existing count variable. And if it doesn't contain, we are anyway going to add it to our map. So we'll add map1 dot put. The key will be the sum itself that we have got, the current running sum, and against that we have to get the current count. So we'll use this get or default. If the current, if it doesn't exist also, we are going to set a default value to that. So we are going to do get or default of this plus 1. So initially we'll set this to 0 plus 1, that is the first occurrence will be the 1, and if it does already contains any value against that, so we are going to take that value and increment that by 1. So all of that happens inside the loop, and outside of that we just return whatever count we have collected so far. Yeah, now we'll run this. And submit. Okay, so yeah, that's all about this question, how to find the total number of subarrays whose sum exactly equals to the given k. Hope you guys have enjoyed the session for today. Do let us know in the comments below if you guys have any questions or doubts, or you want to share any feedback on this video. If you have enjoyed the session so far, do hit the like button so that this can reach out to many more people. And if it does, it just gives us enough motivation to put out more such content. Also, if you are looking forward to more videos like this, please don't forget to subscribe to the channel and press the bell icon next to the subscribe button to never miss an update on our upcoming videos. Thank you so much for watching.